So by a whitening operator, we can know special conclusion is theory 5.3. We know from the pattern we can know L, U, and X. So we know X, U, and P, U. P from U, it has the same information. So it's important conclusion. After that, we can consider about the next step. The next step is important because multiplicity is very hard to get the definition. But if we consider a Booth-Kernel case, we can know a little about the multiplicity. In the Booth-Kernel case, we got a information from the Booth-Kernel. It may be the whole line of my paper. So it's just to do something in my this year. Also, I hope everyone can like a little about
definition. If the deal says the definition of Booth-Kernel.
FG の。Let's back the theory to 5.2. If the Booth-Kernel has the pattern F1,
exact expression of just generally Brodsky and the linear movement.
So in the theory 5.2, if we give the special condition of the f and g, and we try to fix g and to modify the f, we can make the Busa-Clonal case to become a Riemann function. And what I mentioned about the Busa-Clonal case is the multiplicity is equal to n. How and what's the important condition of the result? Because we have some condition for G and some condition for F. For G, the condition is GRU. And the condition is very important because the condition is an important case in my whole paper. Second, some condition for F is the Wronski F1 to F1 is not equal to 0, and determine FI also not equal to 0. So we can get the result multiplicity of Fu is equal to F. So this is all what I do in this year. So そのこれは私の1年間の研究報告の発表しました。Hope everyone can like a little about this. Thank you very much. 皆さん本当にありがとうございます。